Okay, welcome back, guys. So we are going to do today still on a section C paper. We are going to do the section C. So as usual, for each of the questions, I will start with some simple explanations that related to the topic. Once you understand about that simple explanation about that particular topic, then we will start to do the question. Doing this way, we are doing two in one. We are doing the revisions and we are doing the exercise as well. Guys, by looking at this question, okay, section C, remember we have done with the section A, B, and C, inshallah. Remember, when we are doing the section C, you always remember you need to explain in detail. Because section C, for each question, they have a bulky numbers of marks. So you must explain A to Z. I always advise my student, when you are answering section C, try to imagine you are explaining to your grandmom. What or your little sister. Why I'm saying so? Because you need to explain each point accordingly in detail. That is how you earn the marks for section C. Okay, so please keep that in the mind. Please explain in detail. So that is one of the hints. Let's look the experiment itself. Two experiments will carry out by a student to investigate a factor that affect the rate of reaction. Oh, this question, by just knowing this, then automatically I know this question is related to rate of reaction. Therefore, guys, I'm gonna do some revision on the rate of reaction. Are you ready? Okay, wow, energy. Energy. Itu yang kita nak Jangan ni ke. Okay, let's look over here. I'm taking something. Okay, in the rate of reaction, first of all, biar saya padam. Okay, when I say rate guys, rate is inversely proportional with 1 over time taken. It's inversely proportional with the 1 over time taken. Therefore, guys, when you have time taken, it could be dia akan jadi 1 over time taken. This is very, very common, 1 over time taken. Some reference book, you will notice that rate is equivalent to a constant divided by the time taken. Therefore, as you can see, the K is actually referred to a constant. Where, how to measure the rate? How to measure the rate? Tell me, there are several ways to measure the rate. Tell me. There are several ways to measure the rate. Very good, very good. The first one will be the easiest one, by measuring the volume. Yes, you have I will start, mass, or you can use the volume, or you can use the mole, or you might use the molar as well. So, divided by the time taken. So, automatically, this is your rate of reaction. Automatically, this is how you should measure the rate of reaction. So, there are several factors that affect the rate of reaction as well, guys. There are several factors, factorial. The factors, what are the first factors that affect the rate of reaction? Tell me. Yes, okay, we have 5 factors. For your information, we do have 5 factors that affect the rate of reactions. The first one will be the size, or sometimes they refer as a surface area. They refer it as a surface area. Other than that, they refer as a temperature, and we do have a concentration. Okay, and we do have what else? Catalyst, and the last one will be pressure. So I will go through briefly about each of these topic. Guys, in order to, if you want to go in detail each of these topic, I really advise that you can go through my YouTube channel. Okay, because I already put everything in my YouTube channel. You can have a look and have a good, a better understanding. I just going to cover a smaller portions. Okay, when I say the surface area over here, guys, the smaller the surface area, this is a very simple one. The smaller the surface area, what happened to the rate? Tell me. Tell me what happened to the rate. Hey, hey. The smaller the surface area, the higher the rate of reaction, because more surface area that exposed to the, what do you say, uh sorry, this is about, okay, I'm talking about size. Yeah, sorry, you are right. Okay, the smaller the size, the bigger the surface area. It's a vice versa. Sorry, guy, a girl. Okay, the smaller the size, the higher the rate of reaction, because smaller size do have a bigger surface area. Okay, sorry, for that part. And also, when you have temperature, when you are talking about temperature, the higher the temperature, the higher the rate of reaction, because due to higher kinetic energy. On the other hand, the concentration pula, higher the concentration, the higher the rate of reaction. Why? Because higher rate of concentration stand for amount of particle increases. When you have a higher amount of particle, that's called more effective collision. When you have more effective collision, eventually this cause higher rate of reaction. The frequency of effective collision increases. Okay, so far so good, guys? Okay, good. So, on the other hand, okay. On the other hand, catalyst. Catalyst, guy, it doesn't mean you have more catalyst than you have a higher rate of reaction. No. It actually, with the presence of catalyst, dia macam ni je. Kalau ada catalyst, cukup. Then the rate of reaction will increases. Okay? The rate of reaction will increases. Why? With the presence of a catalyst, the activation energy decreases. Okay, you must remember that catalysts provide an alternative pathway. The catalysts provide an alternative pathway to alternative pathway, which is lower the activation energy and provide a higher rate of reaction. Please keep this in mind, ya. Sangat penting. Okay, and also pressure, guys. When you are talking about pressure, dia kan high. Okay, pressure you must keep in mind. It's only valid for a gas system. Why? Because only gas system you can compress. Only gas system you can compress. You can't compress solid. You can't compress your liquid substances or aqueous because of the particle arrangement and so on. So with the pressure, with higher the pressure for gas system, higher the rate of reaction. Okay, higher the rate of reaction. Why? Why? Because when you compress a gas, the distance between the particles getting smaller. It means they are coming closer. When the gas particles are coming closer to each other, they will collide more frequently, which is increase the effective collision and automatically it increase the rate of reaction. Do you understand? Okay. Yeah. Aman? Ada soalan ke? Oh, okay. So, Okay, now, okay, siapa nak screen capture, you can do it now. You hurry up. I'm going to erase this part. Okay. Done. Okay, guys. About the rate of reaction, of course, a reaction stands for when you have a reactant and you convert the reactant to product. And you convert the reactant to product. Reactant to product. Okay. Guys, they very commonly, they will ask you to change this reactant to product in the form of graph. So therefore, you have a reactant graph, and of course, you have a product curve. You have a product curve. So you have on this hand, remember, the y-axis might be, I'm talking about might be, it could be mass, or in fact, it could be volume, or sometimes when you go to higher level, you will learn more example like a mole and molar. And on the x-axis, my dear student, it will be in time. Normally, we measure in second. Okay, so what happened? Okay, if I'm talking about reactant, kalau is about reactant, bahan, when you do an experiment, bahan dia akan semakin habis. Remember, when you are talking about a reactant, during the experiment, the quantity of the reactant will be used up. Use up ataupun habis stand for the amount decreases. So based on the graph, if you look at the graph, if the graph is going downward for a rate of reactions, I'm actually talking about reactant. But on the other hand, if I'm talking about a product, also the y-axis will be almost the same. The time will be over here, second. And product during an experiment, product will be formed. Kalau buat satu eksperimen, hasil akan terbentuk. Bila hasil itu terbentuk, you must remember the amount of the product will be increases. Therefore, the graph will going upward. And also, I have teach most of my students earlier, rate example, I take a very simple example, rate equivalent to mass over time taken. Okay, this is a very simple example. And by looking at the graph, by referring to the graph above, the mass is located at the y-axis. And the time is located as the x-axis. Y and X. Y and X. Okay, so by just looking at the formula y over x, you have learned in your mathematics, y over x is actually referred to the rate, and y over x also referred to the gradient of the graph. Sebenarnya kalau dia suruh kira kadar tindak balas daripada graf, sebenarnya dia nak kita kira kecerunan graf. So, remember, guys. So, let's say you are interested a particular point in the graph. So, you draw the tangent line. Guys, this is just a revision. I'm not teaching one by one. Okay? I hope you can recall what you have learned during your earlier chapters. If you can't recall, then you go to my playlist in YouTube channel and have a look. Okay, so this will be sometime how to calculate the gradient. The gradient can be calculated y2 minus y1 over x2 minus x1. Therefore, the formula can be simplified as the delta y over delta x. Delta y over delta x. Therefore, referring to the graph again, you have a delta y over here and delta x over here. On the other hand, If let's say you are interested on this particular point, it's very easy. You might draw the tangent line like this and the triangle delta y and delta x. Then you can calculate the rate accordingly. So you might screen capture this thing. Hey guys, if you have a question, you can ask me immediately. Jangan hold. Okay, done. Done. Carl, dah ke, Carl? Suara pagi-pagi mengantuk. Baguslah. Okay, I'm gonna erase this. Okay, guys. Okay, let's say you are given a graph, something like this, and you are drawing like this. By just looking at the graph over here, you notice this is a product or reactant. This is your product or reactant. It's a product, very good. Let's say I give you a 3 different point. Point A, B, and C. Okay, and also you notice after point C, after the point C, the graph become constant. The line become constant. It's a constant. Guys, what do you understand and why it become a constant? Tell me. Why it become okay, because very good. Very good. Very good. So that's how you do it. Very good, yeah? So at this point C, all the reactant has been used up. So or sometime it is also called as the end point. Sometimes point C also called as the end point. End points mean end of the reaction. End point stand for end of the reaction. Okay, done. Okay, done. Okay, guys, I would like to tell you, I would like to ask you. Let's look. Tu Datin dah bersuara dah. Aiman baik hang jawab. Sebelum mahang ambil tayar basikal pukul hang. Tak. Buat apa? Biarlah jadi Sekejap, saya hantar gambar ke orang, nama ke orang. Jadi isu pula. Okay. Okay, dah. Okay, done. Okay, let's look point A and B, guys. I would like to ask you, which gradient is much steeper? Why? Okay, I rasa you punya internet sangkut-sangkut ke kau punya suara yang sangkut-sangkut? Okay, so of course, the gradient of A is steeper than the gradient of B. This indicate the rate at the point A is higher as compared to the rate at the point B. You must remember this at the point B. So that's why lah, my dear guys, at this particular point, point C, the rate we call is an endpoint. When we call this is an endpoint, automatically this is referred to a rate that equivalent to 0. That's how you do it. That's how you do it. Okay, guys, please can capture this thing. Jangan padam. Okay, padam eh? Okay, now you look at here. Now you look at here. I'm going to talk about the last section of it, the collision theory. The collision theory. Okay, guys, when we are talking about the collision theory, it's always interlinked with effective collusion. Dia selalu berkait dengan effective collusion. Okay, guys, when I say effective collusion, what do you mean by effective collusion? Is the collusion that cause a reaction. It's the collision that cause a reaction. Dia adalah pelanggaran yang menyebabkan berlakunya tindak balas kimia. Pelanggaran yang menyebabkan tindak balas kimia. Maksudnya stand for when there is an effective collusion, therefore it will change the reactant to product. The reactant to the product. Okay, whenever you have an effective collusion, therefore it will change the reactant to product. Guys, there are three, the effective collusion factors. There are three things that you need to remember that cause the effective collusion. What is the first one? What is the first thing in effective collusion that you need to know? In order for effective collusion to occur, what is the first rule? The first rule, yeah. Hurry up. Very good. That is the wrong answer. In order for an effective collusion to take place, my dear student, You must, the molecule. Sekejap saya tukar pen sekejap. Tak best hijau. Dekat sini pula limited colour sahaja. Sorry lah. The molecules must collide. Must collide. You nak a reaction to take place, you mestilah berlanggar antara satu sama lain. Tak langgar maka tak ada reaction. Kan? Kalau kamu pergi je tengok Aiman, tak ada apa-apa reaction. Cuba kamu pergi tumbuk Aiman. The reaction happen immediately. That's how the reaction happen. Okay? First thing, you must collide. The molecule will collide each other. Tumbuk Aiman. Bila tumbuk, ada reaction. Next thing. What is the next thing? You must... Someone want to try? Okay, try. Terus jangan jawab. No. No, baby. But it's a good try. That is a third factor. The second must be at the right orientation. Right orientation. Dia mesti berlanggar pada kedudukan yang betul. Dia mesti berlanggar pada kedudukan yang betul. Contohnya, you nak tumbuk Aiman. Janganlah pergi ke Aiman, kononnya nak tumbuk tapi pegang pipi dia. No. Tumbuk dengan kuat-kuat. Okay? It must at the right orientation. Jangan just pegang je. Okay. The next one just now, right orientation. Okay, first is must collide. Second at the right orientation. And the third will be, macam yang tadi Aiman cakap tadi, is a minimum. It must have a minimum kinetic energy. Kinetic energy. Or in the other word, they call it as a activation energy. Activation energy. This is also called as a activation energy. This is also called as a activation energy. Okay. What is activation energy? The minimum energy needed to change a reactant to product. A minimum amount of energy needed that need to change the reactant to product. In the other word, is the minimum amount of energy needed to have a reaction to take place. For a reaction to take place. Okay, done. Very good. Senang padam. Okay, guys. For me, that is cover the basic. Do cover the basic. Even though I didn't go through one by one in detail, that is the basic that you need to know. Because by saying that, you already can get some basic idea. Because you have learned this chapter earlier. Remember, now we are approaching to the SPM. We are going to the SPM. So therefore, for me, it will be, you already have the basic idea and the theory. So I just recall what we have learned earlier. So now you look at the question. You have a factor that affect the rate of reaction between the metal Y and metal Y and Z acid. Apa ni acid? And Z acid. Oh, okay, I understand. Okay, now you look at the question. You have number one. You use this one in excess. Guys, can you tell me why you use this thing in excess? Any idea? Okay, very good. You have the idea, but the thing is, girl, can you make it shorter? Yes, to ensure a complete reaction to take place. To ensure a complete reaction to take place. That's why you are using in excess. Okay? So and you have 50 cm cubic of this thing and 1 molar. On the other hand, on the other hand, you use the excess granulate metal Y. Guys, actually, in this particular question, what factor we are going to discuss? Very good. The size is a factor. You have a size as a factor. Okay, the powder do have a higher surface area. Okay, higher surface area. Of course, it is smaller in size, higher surface area. On the other hand, the granulate, the size is bigger and the surface area will be smaller. Automatically, you already get a clue that you know that, my dear student, the first one going to have higher rate of reaction. Okay. Don't so excited answering the question. Try to understand the need of the question before you really answer the question. And on the second one, you notice the rate will have a lower rate of reaction. Guys, how can you relate this with the time taken? As you have a higher rate of reaction, definitely you have a shorter time taken. When you have a lower rate of reactions, definitely it have a higher time taken. Okay, understand? Understand? Okay, janganlah nangis. Okay, saya nak padam ni. Okay tak? Name one example of metal Y and one example of acid, Z acid. Tell me. Okay, why not? Why not? Yeah, I agree with you. But girl and boys, listen. They ask us to name. Name. When they ask a name, you need to spell it out. Spell it out. So you're gonna use a zinc and a hydrochloric acid, yeah? Hydrochloric acid. Okay, spell it out. Aiman, nampak tak? Name. Spell it out. Okay. So this one, you already carry. Dia tengah layan handphone. Tadi bunyi? Zek. Oh. Hey, aku ni sensitif tau telinga saya. Walaupun aku tak nampak kau, Aiman, saya punya roh sebelah kau je. Wah, gitu. Seramnya. Aku buka hari ni serabai lah. Sebab aku pagi je aku bangun. Tapi itulah, tak sempat nak buat apa-apa. Inilah muka saya. Siapa nak tengok? Let's look. Boleh? Baguslah. Okay, this already get a 2 marks. Okay. Okay, this already 2 marks. By using the metal Y and the Z-axis name, write a balanced chemical equation for the reactions occur. Lah, senangnya. Okay, my dear student, you have a zinc, you plus with a hydrochloric acid, then you will produce a zinc chloride and also hydrogen gas. Therefore, this is not balanced because the one and the zinc is balanced, and the HCl, you have 2H, then you put a 2 over here. Yes, it is balanced. It is balanced. Okay, this carry another 2 marks. So total of 4 marks is given for just answering like this. Done, my dear? Good. Okay. Ya, yeah, betul. Tapi kan betul. Nama dengan equation. Tapi, if you are confident enough, this is my suggestion, you letak dia punya state. Contohnya, zinc is solid, hydrochloric acid is aqueous, this is aqueous, and this is a gas. Will be better lah. Will be better. Bukan kena letak. I cakap better. Kalau tak letak, tak apa. Sebab dia tak specifically mention pun. Cumanya, kalau kita letak solid, aqueous, and gas ni, nampaklah budak ni, wow, hebat. Tapi, jangan cari maut, tiba-tiba, you salah letak. One of it. Contohnya, zinc should be solid. Tiba-tiba you terletak liquid. Entire of the thing become wrong. You get 0 mark. Siapa ni? Jangan. Alisha, sabar Alisha. Alisha, sabar. Tarik nafas. Jangan nangis. Okay. Now you tell me, what is your problem? Okay. Oh, it's a very good question, Alisha. I think, in fact, I have explained this in the previous classes. Okay, when I have heating, when I undergo heating, then that is stand for heat until melt, that is liquid. When I do a solution, that is aqueous. Contohnya, contohnya Alisha, do you still remember about naphthalene experiment? Experiment on naphthalene? Okay, when you heat that particular naphthalene, the product that you get after heating is what? You call that as, yes, liquid naphthalene, because you do involve the heating process. But molten is actually liquid. When you take that, we never ever call aqueous naphthalene, because you're not dissolving that naphthalene in water. So, in a simple term, molten is liquid and solution is aqueous. Okay. Sebaik Alisha tak nangis. Okay. Aiman. Ada yang sekali kita pergi rumah one of the girl buat kelas tu. Siapa nama dia Alisha ke? yang kita pernah buat kelas tu, kamu dengan one of the girl dengan Is. Oh, Dania tak ada Oh, ada. Dania, kenapa kamu diam? Hei, Dania pergi mana? Apa yang berlaku? Okay, tak apa. Okay, guys, now you look this one. Try to do this. Siapa tu? Oh, Alicia. Engkau pun diam. Mungkin dia tengah main-main dengan kucing dia. Jadi kau tengah main dengan apa pula? Rahil, why you late? Oh my god, that's very bad. Never mind, next time I do a wake-up call for you. Is, you also late. Late lah tu. Oh, tak apa. You dekat dalam mana ni? Server room ke? Okay, tak apa. Yang lain semua awal. Okay, are you ready guys to do this? Okay, calculate the average rate for the this one, experiment 1 and experiment 2. Average. When I'm talking about average, look at here, my dear student. Okay, look at here. This is the one of the clue. They produce 30 cm cubic hydrogen gas. Therefore, the calculation of the rate for this particular experiment will be volume divided by time taken. Therefore, the volume is 30 lah. Okay, and the time taken is either 10 or 20. Therefore, the rate will, okay, for the first one, experiment 1, will be, the volume will be 30 cm cubic and the time taken is 10 seconds. Therefore, is 3.0 cm cubic over second. On the other hand, experiment 2 will be also the same volume, 30 cm cubic over with 20 seconds. Then you get 1.5 cm cubic over second. Bingo. That's it. Okay, done. Done? Okay. Okay, good. Now, compare the rate of reaction between experiment 1 and 2. Okay. What can you say? I can say? No. You compare first. They ask you, compare the rate of reaction between experiment 1 and 2. You answer the first question first. So what should you start? Experiment 1 have a higher rate of reaction compared to experiment 2. That should be your starting point. So, experiment 1 have higher rate of reaction as compared to experiment 2. This will be 1 mark. Okay, 1 mark. Let's look at our question further. Explain your answer by using collision theory. Mamma mia. Guys, collision theory, we have how many factors of collision theory? Tell me. I have explained. How many factors that affect the collision theory? Pardon? Collision theory ada berapa? No, that is the rate of reaction punya factors. 5 is rate of reaction. Pardon? Yes, you have 3 factors. Okay, guy, 3 factors stand for 3 marks. And also over here you have 1. So 3 plus 1 equals to 4 marks. That is how you get the full marks. Okay, but you must explain in a proper way how to put it into the words. Let me explain. I erase this first. Okay. Okay. So you're going to do what? Explain, smaller particle. Okay. Which experiment have a smaller particle? Which experiment have a smaller particle? Pardon? Experiment 1, Experiment 1. So what we are using what, girl? It's a metal, am I right? Okay. Jadi kita betulkan sikit dia punya ayat. Metal. Why in experiment 1 do have a smaller size, am I right? Size with larger surface area. Okay. Area that expose for reaction occur. Okay. Sebab dia punya saiz kecil, lebih banyak luas permukaan yang terdedah untuk berlakunya tindak balas kimia. Okay. Then, the second one, what happened? This will cause more what? Collision between the metal Y and Z acid. Okay. When it have more collision, what type of collision? Tell me. What type of collision? Very good. You're gonna have more effective collision. What do you mean by effective collision, guys? What do you mean by effective collision? Effective collision is a product. It produces a product. You are right, but it will better. It will better. Effective collision increases. Effective collision increases, which stand for what? A collision at right orientation. Ah, you must see that right orientation with minimum activation energy. Minimum activation energy. EA. Therefore, the final answer, the uh, therefore, it have higher rate of reaction. Okay, ini semua 4 markah. Guys, korang perasan tak satu benda? Untuk section C ni, normally kita akan jawab lebih panjang, lebih detail, more word, explain A to Z. This is how you should answer section C question. So each one of these will carry 1 marks. Each one of these will carry 1 mark. That's how you should do the section C. Do you get a basic idea about it? Okay, that's cool. Okay. So I'm gonna, okay, siapa nak screen capture, you can do it now. I'm gonna erase this. Okay, done. And here. Let's look a 10 mark question. A 10 marks question, 10 marks. Okay. Describe an experiment how the factors temperature of reactant or the presence of a catalyst affects the rate of reaction. Okay, actually kan, dia dua soalan tau. Be careful. Be careful. They put or. So which one you are going to choose? Because it's easier, am I right? Boleh je. So, okay, tapi listen guys. If you choose temperature, then I will, of course you will choose experiment sodium thiosulfate. This experiment. If you are choosing a catalyst, then I will advise you to choose which experiment? Tell me. The hydrogen peroxide. The hydrogen peroxide. The one use the manganese oxide as a catalyst. A manganese oxide as a catalyst. Okay, you can use either two. So, in my opinion, how to get the 10 marks? What is the starting point for a 10 marks? Remember, for this type of question, guys, first of all, you must have a diagram. I give you the orang kata rangka, the framework. Then once you have this, please write a chemical equation, and followed by the steps, and you discussion. Those are the steps that need to put it over there. Yep. H2O2 is hydrogen peroxide. H2O2 is hydrogen peroxide. Okay, done? I'm going to teach you step by step how to do this. Don't worry. But this is the framework. Definitely this will be the framework. Yeah. Takkan anak. Okay. Okay. So let's say I'm going to choose the temperature. I love the temperature. So you need to explain. Okay. So saya padam ni sikit. So start with the diagram. You have the flux. Ingat tak eksperimen mana yang kita nak buat? Yang ada kertas tanda X hilang tu. Okay, you have this thing over here because the question asks us to describe. Then you need to do step by step. Of course, you will put your eye. Hey guys, during SPM, please draw and label. Don't just draw because some of you drawing boleh menyebabkan fitnah. Kita tak nak ada fitnah. Okay? Lukis conical flux pun nanti jadi pelik. Okay, in this case, my dear student, what are you going to do? You have a piece of paper, put it over here, and the X mark. So, what are the substance you are going to add? You have a sodium trisulfate, okay, and you will put with a hydrochloric acid. So, from the diagram, you come out with the equation. From the diagram, the equation will be Na2S2O3 plus HCl. Guys, do you still remember how to do this? Very good. No answer. And this one will break accordingly. This one will break accordingly. Pecahkan dia kepada cation and anion. It become Na plus and S2O3 2 minus. And over here it become H plus and Cl minus. Guys, I have told my student this thing can be further break. Dia akan pecah jadi apa? Dia akan pecah jadi SO, sulfur dioxide, and also oxygen, and also sulfur. So maksudnya Na ni dengan Na dengan Cl combine. Therefore, it become Na2S2O3 plus HCl, and it become NaCl plus this and this cancel out, and the H over here and the oxygen will combine to form H2O, and since you can notice this one and this one doesn't have any charges, then you just write it down, sulfur plus sulfur dioxide. But nevertheless, this equation is not balanced. The equation is not balanced. You need to put the hydrogen is 2 over there, my dear student. So you put over here 2. And the 2 NaCl because I have 2 chlorines, 2 sodium. And yes, now it is balanced. This is your balanced chemical equation. Guys, you have a diagram, you have an equation. What is next? The procedure. Very good. So, how to do the procedure? Guys, for the procedure, especially for section C, guys, section C, you must be very precise. What do I mean by precise? You need to mention, for procedure, section C, you need to mention the volume, the exact volume, and also you must mention the mole of the chemical that you are using. The molar, molar. The molar that you are using. These two things are extremely important. So maksudnya, you kena tahulah berapa sodium thiosulfate punya volume and molar, hydrochloric acid punya volume and molar. You might wondering, sir, I do not know how much to put it. Guys, as long as you put a logic answer. A logic answer. Don't too extremist. As long as the answer is logic, then it's acceptable. Paham? So, what will be the first one? Guys, sodium thiosulfate. Korang nak, okay, I will say, 20 cm cubic of 0.1 molar sodium thiosulfate. Sulfate. Guys, this is a logic. Mestilah orang guna dalam ni bika yang kecil, 20 cm cubic. Janganlah tulis 2 liter. Kamu ingat kamu buat eksperimen dalam baldi ke? No. That's why you use 20 cm cubic. Janganlah more than 1 molar. Because takut nanti terlalu pekat jadi dodol. Use something in between 0.1 till 1. That is acceptable. Sodium thiosulfate solution is measured Please use a past tense, guys, sebab benda ni telah berlaku. Continuous past, past continuous macam tu lah. Okay, so you boleh letak yang ni kan, formula terus. Na2S2O3. Kenapa letak formula? For the next round, you tak perlulah setiap kali aja sodium. Terus guna formula. Na2S2O3. Tapi for the very first time, you need to spell it out. Subsequence, then you don't need to spell it out. Then the Na2S2O3, the procedures. Solution is then pour or mix into a conical flux. Bang, nyo ni nak tulis. Okay, you might screen capture this thing. Dah. Humans, are you with me? Yeah, very good. I'm going to erase this. Saya padam Okay, good. The next one will be the third point. The initial temperature of Na2S2O3 is recorded. Recorded. Nampak tak saya buat sangat-sangat detail A to Z, step by step. Inilah cara nak jawab section C. And the conical flux is placed on the top of a piece of white paper marked with X. Then you ada hydrochloric acid. Ini dah ada dekat dalam flux. Now you're gonna talk about hydrochloric acid. I will say take 5 cm cubic, 0.1 molar hydrochloric acid. For the first time, you spell it out. But bracket HCl because you can use on the next steps. Is measured the HCl acid is poured quickly into the conical flux. And banyak kan? Dah tambah, kita letak apa? Kita nak measure the time. Use a stopwatch. A stopwatch is started immediately. Okay. Hurry up. Screen capture or write it down. Hurry up. Kita ada banyak lagi step. Sebab dia 10 markah. So you do one by one, each of it. Done? Okay, done. Kalau done, I'm going to erase this. Okay, what are you going to do next? Stopwatch. What shall you do it next? Pardon? Ya, betul. Tapi it will be better. The conical flux, you kena pusing-pusing dia sikit. Ingat tak? Is swirled throughout the experiment. Then, dia pusing-pusing sikit, baru tengok dia punya observation. Sebab kenapa tau? Kalau you just campur je kau biar, takut dia tak mix well. That's why we need to pusing-pusing sikit to ensure that the things has been mixed well. Understand? Okay. Okay. The time taken for the mark X to disappear here from mind is recorded. And the experiment, last step, experiment is repeated using Na2S2O3 solution at 35 degrees Celsius. Kita repeat lah balik. 40 degrees Celsius, 45 degrees Celsius. Letaklah yang logic punya As long as dia logic, then okay. And 50 degrees Celsius. Dua tiga lah. Letak dua atau tiga different temperature. Yeah. No. You are not going to put a Bunsen burner over there. You heat the solution. You warm the solution in a different beaker or flask. Then you measure the temperature. Then once you have measured the temperature, then you put into the flask. That should be the procedure. You are not going to do direct heating. No way. I do understand that. Okay, please write it down. This for this part.